that I'm multiplying it by 30 over 1. I'm multiplying by 30 over 1. I'm multiplying by 30 over 1. I'm multiplying by 30 over 1. Because I will simplify before multiplying. I will not multiply. I will simplify. So I will simplify 5 and 30, and I get a 6. So negative 42x plus. I'll simplify by 2, and 15 times 15 is 225. I will simplify by 6, and I get 22, I think. I'm going to check in a minute. So when I simplify by 5, I get positive 18x. So it's 235. 5 times 7, 35, 5 and 3, yes. So as you see, in one tiny step, by simply multiplying everything, all factors, all terms, all fractions by 30, I made this ugly looking equation collapse into a very simple linear equation. Yes, I will move the terms around accordingly. I will move 18 next to negative 42, and I have to change its sign. And I will move 25 to the other sign, changing its sign. So 42 minus 18, negative 42 minus 18 is negative 60. 235 minus 225 is 10. Is this step clear? Let's think for a moment. Anybody has questions on this? Please don't be shy. This was positive. I moved it to the other side. It becomes negative. Negative 42 minus 18 is negative 60. 235, I subtract 225. 235 minus 225 is 10. Now I have to divide by negative 60. So I get negative 1 over 6 because at the same time I simplify both sides by 10. Or I divide both sides by 10. And that is the final simplified form. This is not a trivial equation. Yes, I made it look easy, but it's not a trivial equation. You have to be careful. You have to know how to find LCD. You have to remember to simplify and then carefully multiply and so on and so forth. It's not that easy to verify. How do I verify this? How do I verify that this is true? Okay, so the original equation was negative 7/5 x plus 15/2 47/6 plus 3/5 x. Okay. I think that was the original one. Was it? Did I copy it incorrectly? Negative 7/5 plus 15 minus 47, 3/5. Yes. So when I go to the graphing calculator, I know I have it here, but who knows where it is. Okay, here it is. Good. Here's how I check. So the left-hand side, parentheses, negative 7 divided by 5, close. I multiply by negative 1/6. Negative 1/6. And then I add 15 divided by 2. So I got some gibberish of 7 point la la la. Now I'm checking the right-hand side. 47 divided by 6, and then plus, in parentheses, 3/5. Again in parentheses, negative 1 over 6. When I click enter, I have to get the same gibberish. If I don't, I'll say, oops, negative 1/6 is not the solution. I have to go back to the drawing board, and if I don't get the same thing, I'm in trouble. So I did get the left-hand side to equal the right-hand side, replacing x by negative 1/6. So obviously that is the correct answer. And no other. This is a conditional equation. It's not an identity, and it's not a contradiction. It has one solution. Okay. I think this is the same, much easier than the previous one. Okay, this is slightly different. Here is y. And now you tell me what you want to do with this one. So 4/7 x plus 1 equals 1/14 x plus 5. So here we have at least two options that I would recommend. So 4/7 quantity x plus 1 equals 1/14 quantity x plus 5. Okay. One option would be to multiply both sides by the least common denominator. Here's the other option before you decide. What is this? It's up to you. We find the least common denominator, but you have to be very careful. Where are my props? You have to be very careful because we only eliminate the front and then we still have to distribute, which is fine. That's perfect. The second option is this is the same with this. Why? Because this is over 1. 4 times the numerator times over 7 times 1. 1 times the numerator over 14 times 1. Everything is over 1, unless it's 1 over. So we have this option and you multiply by the least common denominator. Well, we have this option and we cross multiply. You decide. Both are fine.
I'll take the fork.
You take the fork? I agree with the fork. But remember, you have to see it like this. If it's not clear for everyone that this is the same with this, simply multiply both sides by 14, the least common denominator. But be very careful how you do that. We're going to solve it in both ways. Okay, so here, 4 times 14 is 56 x plus 1 equals 7 times x plus 5, 7 quantity x plus 5. Again, 14 times 4 is 56. 7 times x plus 5. Why? Because this is a proportion. In a proportion, we are allowed to cross multiply. So now I have to distribute 56. 56x plus 56 equals 7x plus 35. Again, in one little step, the whole thing that looked scary is just a linear equation. But now I have to move terms around. I have to move 7 next to 56, and I have to move 56 next to 35. Of course, changing the sign. So 56 minus 7 is 49x. And here, careful, because it's a negative number, it's going to be 56 minus 35, and this is 21. But it's negative, because I'm bringing negative 56. So 56 minus 35 is 21. Of course, I have to divide by 49. A negative of a positive, I will already make it negative in front. So I don't have to write it again. Yes, this is not fully simplified. Top and bottom have a common factor, which is 7. So the simplified form is negative 3 over 7. And this is the final answer. Let's see what we get with the other one. We have to get negative 3/7. Otherwise we make a joke out of math. So let's do that. When we multiply both sides by 14, we simplify before we multiply. So times 14 times 14. Here's easy, nice. Here I simplify by 7. So then I have 8 with x plus 1 and x plus 5. I distribute 8x plus 8 equals x plus 5. I move x next to this and I get 7x. I move 8 next to 5 and I get negative 3. And it better be the same thing. Any questions on these two procedures? Numbers were a little bit bigger on this side, but of course the same thing. Okay, moving on. Let's see if there is anything else that we need to address. Again, this error thing to follow through. Okay. Yes. So this is a different situation. 1.1y minus 1.4 equals 2.2y. Now, exactly what we did before, we eliminated fractions because this is so much easier to handle than this. The same idea with decimal numbers, with equations that involve decimal numbers. Is it recommended? Will I say it's carved in stone? No. But it's highly recommended to eliminate decimal numbers. So I have 1.1, I have 1.4, I have 2.2. In each number, I see only one decimal digit, which means that I will multiply both sides by that quantity needed to eliminate one decimal digit. What will I multiply both sides by to eliminate one decimal digit?
10.
Just 10 indeed. And now the equation will become easier to handle because I'll have 11y minus 14 equals 22y. I will only move 11 to the other side, 11y. 22 minus 11 is just 11. So the right-hand side is 11y. The left-hand side is negative 14. All I have to write is y equals negative 14 over 11. If they want us to change it into a mixed number, we will. If they want us to have it in the simplified form, lowest terms it is already. Simplify your answer. Give the smallest power of 10 by which, okay. So it has, let's see, 10, of course. And then do not solve. Okay, so you're going to have to write 11y minus 14 equals 22y. Okay, the same thing. What will you multiply in this case by? 0.72 minus 7x equals 1.1x. I see two decimals, and I cannot pick and choose. So if I multiply by 10, I have to multiply everything by 10. If I multiply by 20, I have to multiply everything by 20. If I multiply both sides by 100, I have to multiply everything by 100. So what will I multiply by? 100. All of them. Don't pick and choose. Solve the equation by multiply by a power of 10, the same thing. We already did this. The same thing, multiply by a power of 10 first to simplify. Okay, same thing, you will distribute first and then eliminate. Okay, let's see if we want to look at any of these before we continue. This is a good question. We're going to talk about this one. So do we need any of these examples? So let's look at 19. When solving the equation ax plus b equals 0, how can you tell when there are infinitely many solutions? The equation simplifies to an identity such as negative 3 equals 3. The equation simplifies to a contradiction such as 4 equals 0. The equation cannot be solved. The equation simplifies to an equation which is true for only one value of the variable. Which of these parts is correct? Again, when solving the equation, how can you tell when there are infinitely many solutions? When we get negative 3 equals 3, when we get 4 equals 0, when we cannot solve, or when the solution is either x equals 5, or x equals 15, or x equals 20.
D.
Which one?
Delta.
The equation has to simplify to an identity.
No,
Infinitely many solutions. The equation has to simplify to an identity.
Yes.
Okay? So let's go back for 1 second before we click enter. The left-hand side has to be identical with the right-hand side. And it can be negative 3 equals negative 3, 0 equals 0, 10,000 equals 10,000. As long as the left equals the right and there is no x, it means that x can be anything. Infinitely many solutions. So again, let's go back. So, an identity or infinitely many solutions gives us a true statement forever. This is false because the solution exists. They have infinitely many solutions. The equation was solved. And it simplifies to an equation which is true for one value, that is conditional. So it's just A. It has to simplify to something that is always true no matter what x is. If solving an equation results in 0 equals 4, how many solutions does it have? Exactly none. Very good. If solving an equation results in 0 equals 0, how many solutions does it have?
One.
Infinitely many solutions. Infinitely many solutions. If it's 0 equals 0, and we did not determine x, it means anything goes. Solve x plus 11 equals x plus 11. What type of equation is this?
Identity?
Identity. How many solutions will it have?
Infinite?
Yes, infinitely many solutions. Good. Okay, 7 equals 7. Which one?
N?
Good. Solutions?
All real numbers.
Good. X equals 1.
Conditional.
Good.
1.
Negative 5 equals 1.
Condition?
How many solutions? This is the symbol for, okay. So, this symbol is the Greek letter phi and symbolizes an empty set. Not even 0 in here, nothing. Empty, vacuum, okay? Nothing. The empty set is phi, the Greek letter phi. Nothing. The empty set. Good. That's what this is. So what does it want? Okay. Got it. So the equation state was a condition, identity, contradiction, identity, or conditional. So 24, 25, 26, they're all the same. Please choose one. 27, 28, 29. This has fractions in 28. 29 fractions, 30 fractions, 31, 32. 31 has decimal numbers and 32 decimal numbers. So which one to identify whether it's a contradiction, a conditional, or an identity?